Now that we have our movement for the rook ready, or at least almost ready, still some couple of fixes we need to do, but the idea here and the refactor is done. It's time for us to do the same with the other pieces. Let's go down here and then start doing with the knight. We have already a function that is check valid move, which will verify if our moves for the knight are valid. Differently from the rook, we don't do force because we don't need to go through the whole row and the whole column for the knight. We just need to check if all these moves, the 8 possible moves for the knight, are valid or not. So instead of sending valid moves.push, what I want to do is to call this function check valid move for each of those. So technically our code would look something around this. Const first move, check valid move, and then I'm going to send the parameters, which will be first the board, then the square, and now the coordinate, which will be this one. This will be our first move. And now I'm going to say if first move dot move valid moves dot push first move. This would dot move. This would be kind of the logic we have, but we're going to do if, more ifs, more ifs for each of those moves. And I don't think that's the best idea. So what I want to do is actually to go directly for this check valid move, like so, and then add the move. Simply like this. We're going to need to change something though in order to accept receiving the move directly of this check valid move, because if this move is null, it means that this is not valid. We are going to add a null inside our valid moves, which as of now is only an array of coordinate model. So we could transform this in array of coordinate model or no, and now we accept it. However, this brings a problem in our end because valid moves dot filter move can potentially be null. So we're going to filter it and say if move first before all of it. TypeScript though will complain saying that this is not assigned to type of coordinate null. What we can do instead is to remove this, let it this if this filter be just like so, and before we filter, we're going to filter as well the moves out of that. So I'm going to add this check in a filter before, because now TypeScript understands that the result of this will always be a coordinate model. This only works, if I'm not mistaken, from TypeScript 4.5 onwards, but it works pretty neatly. So now this will always return a coordinate model because the nulls will always be filtered out. And this is the idea of checking if the moved is valid or not, just like we're doing here. Coming back to our knight, then we're going to check if this valid moves and going to add all of them here in the other lines. So I'm going to add it here, 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 all the 8. Maybe speed up the video here. No, you go with me, right? And now on the other side, we just finish it with, oh, too much. Just finish with this. The move. There you have it. So these are the valid moves for the knight. Come back to our application and see if I want to select the knight. I cannot go on top of this pawn because it's a pawn that we have. Now it's black's turn. Go here. Perfect. This pawn here. See that I have all these possibilities. I can even go on top of the knight, top of the pawn. Everything's working as expected. Except, of course, the king, but just like the rook, this is not something we're looking at as of now, because this means that the game is finished. So, wait. The movement of the knight is ready. Just simple as that. Going then to the bishop and, consequentially, to finish the queen, as the first part of the queen is already here with the rook, we need to do a very similar behavior as we had for the rook, here using this get valid moves from row and column. But we're going to see that we need a small difference here. So we have a 4, okay, and then we add all of this. But now, just like with the rook, we need to break this in several different 4s to validate each, in this case, diagonal, not row, not column, but diagonals. Let's start doing that. I'm going to break this first in 4 4s, so just we see this difference. Okay, these are broken down. Now we're doing 4 different fors. Each of these fors technically is the same for that we have here in this get valid moves for row and column, just like we did with the rook. So maybe let's copy paste one of those and try to replace it. Before we start adding our valid moves here with this function, we need to update our fors to be according to the position of the bishop, just like we did with the rook. Instead of starting from 0 and going until 7, we need to make sure that it starts from the position or the position plus 1, just like we did with the rook, as we are doing here, and then we move on from that. But differently from the rook, which increases just the row or the column at once, the bishop does both. So we have the top left diagonal, the top right, the bottom right, the bottom left. These diagonals, okay, are these 4 here, but should we start with the row or with the column? Should we say row plus 1 or column plus 1? It doesn't matter. It doesn't matter, as we just choose one and stick with it. Because if we choose the row and we're going in this direction, that's fine. As long as there's no more columns, it will finish, right? And if we choose the columns and we go in this direction, we don't have any more rows, so it finished. At some point, we'll get to the border of the board, no matter if we're going in this direction or this direction, we always get to the border of the board. Here, the same bottom, doesn't change much here, but let's take the example of the black bishop. So now, if we go by the columns, we're going here, then we're here, 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 and here, and then we stop. In the other direction, the same. If we go by the row, so we go row, then we go row, and rows, and so on. So it doesn't change actually where we start. The only thing that matters is that we keep it consistency. Here, I'm going to choose the row, but you can choose the column, doesn't matter. I'm going to comment this out, at least as of now, so we can test it. And I'm going to say that we're going to start, instead of 0, in row plus 1. Here, the same, you see it's the plus, so I'm going to choose row plus 1, and we're going until 7, at least the limit of our board. In the other case, we're going to be row minus 1, and we're going to stop on the 0. Here, minus minus. Just copy paste this here. And now we have our 4 fours, but starting from the bishop position, or at least the next position. Let's check it out if this works. I'm going to refresh, and if I click the bishop, no, I can still pass over all of them, which is fine because the behavior we had before. We didn't take in consideration yet the blocking pieces. It's what we're trying to do. But it means that our code still works, just like before, starting, but from this position instead of checking from 0. Same, but different. Now, how do we translate these fours into this to make sure that we're taking consideration the other pieces that we already did the whole logic into this function, so we can reuse it? Start position, it's the same, row plus 1, and position becomes 7, increment of 1, and now update row. We need to update the row, true, but the update the column, it's trickier. Because if we say true here, it means that the column will increase by 1. It's what our function does. So checking it here, bit further, we have the new coordinates, okay, which will be column equals I or row equals Y. As this I is always increasing in this case, what we are doing in this implementation here is these 4. We're doing row becoming I and column become I. So how do we do these then? How can we make that the column go into the inverted order? We could create an enum to specify if we want the row to go up, down, the column up, down, and stuff. But a simple way is, instead of calling update row, I'm going to call it row increment. And also have then the column increment. Instead of being a boolean, it's going to be a number, which I'm going to say 1 minus 1, like this. Bring this to our type, so number, column increment. And instead of checking for these booleans, we're going to use these values to increment and or reduce accordingly. So have here row increment. If there is, it's like different from 0, we're going to do something with it. This something is what is a bit trickier to figure out, because we have the increment, okay, here, how many times it passed, like it will increase by this every time it finishes. So now we need to increment this one by the amount of times the for already did times our increment that we have. So what we need is to find out how many times this for passed. You could say here, let count equals 0, because you cannot use I in start position. The start position may not be 0. Most of the time it not be 0. And then just in the end here, say count plus plus, or actually in the beginning here. You could say like this and then use this count, but we're creating a new variable for that, new counter. Not sure is the cleanest way. What we could create is a new variable here inside and not outside of the scope, and say that this count will be math.abs, absolute, which means it will always get the positive number of it, and we're going to say I minus start pos. So the difference between these two values, it will be our count. And now column will be column plus count times column increment. And we're going to do the same for the row, of course. Row, row, row increment, like so. And we're going to update all of our other functions and say update row as it's false, the increment, row increment, will be 0. Update column true, it means that the increment, column increment, will be of 1, like so. Here it will be inverted, column increment is of 0, and the row increment will be of 1. We can apply the same logic now for the bishop, saying that the row increment is 1 and column increment is minus 1. So we go in the inverted direction. Let's then repeat this for all of the other ones. So column increment here will be 1 as well. Now, this is the second for. You can delete these two. Our third for, it will be row minus 1, the start position, ending in 0, and the increment of minus 1. Row needs to go down, and here column goes down as well, so minus 1. And for the last one, we're going to say a column increment of 1. Can delete these two fours. And now we have a very similar logic from what we had for the rook, but going in the diagonals. Let's refresh our page and see how this works in practice. Going to open here this diagonal so we can see the bishop. Going to open also this one for the black bishop, and our bishop doesn't move. So something is wrong for our logic. Let me move this one to check out for the rooks. The rooks also don't move. Our increment somehow is broken. Let's check it out. So let's take a look here and see what is wrong. And maybe you paid more attention than me because I see that this is inverted. So row, column, column here. Row changes row and column changes column, not the other way around. And also the count, it needs to always be at least 1. Otherwise it will never increase here our column and our row. That is fine. If we check out now, we have that. It's a black side, so bishop working fine, but not the rook. Let's check out the rook then. What we did wrong, these are the movements, increment 1, column increment 1, increment minus 1, column increment minus 1. We need to decrease the column here because we are decreasing. And the same problem here for the row. Now the rook is working again. Nice. So have the bishop. Okay, looks good. Have both the bishop and the rook, and also the knight that we did, working as expected. And for consequence, we should also have the queen. So now we can take here the queen. Here we have, that's nice. So almost all the pieces are correct. The pawns, they're already done before, so nothing to change it in them. The logic is already correct. Because the valid moves, no, actually, no, it's not done. What am I saying? No, the pawn is completely missing. So let's add to the pawn the same technique we did for the knight. So we're going to use this check valid move. And if this is not valid, we're just going to remove it later on. So we have it here. Let's add to the 4 of them. Move, dot move, and finally dot move. However, our pawns can still go on top of the other pawns, and this is a problem of our check valid move function. This check valid move allows the pawn, in this case, to go over a piece of the other color, because all the other pieces, they can go up to a piece of other color, except the pawn. The pawn cannot go forward on top of another piece of the opposite color, because the pawn only do that on the diagonals, right? So we can change this function slightly to allow blocking. So block if opposite color. And I'm going to say here a boolean, or come always false by default, so we don't need to change the functions that we already used before. And we're going to make this check here the same. So if it's different color and doesn't block opposite color. And now for the pawn moves, we're going to send a true here for all of them. This should block the pawns from going forward on top of the other pawns. However, we still need to do then the pawns attacking in the diagonals. And for that, it's simply doing the same logic that we have here. So we have the board square, row plus 1, and we're also going to add a column minus 1, so it goes one column to the left. So column is column minus 1, and here column be column plus 1. If we do this, we can go in the diagonal, but only when there is not a piece as we're blocking. We need to create even another parameter here, which we're going to call here. So block if opposite color was false, and allow if only if opposite color, which will be equals false. So we only allow to go there if it's the opposite color, or we could invert this and say block if not empty, or block if empty. Something around this. Block if empty seems a good name for me. And we're going to check here. So if there is a piece in the other one, we're going to check it out. Yes. And if there is not a piece, we'll check if doesn't block, if it's empty, then we can add this move. And here we're going to change this to false and add a new true. So we allow to go on top of the black piece, in this case, because we're using the white as example, and we're blocking if there is no piece there. And now here's the possible movement for this pawn, and this one for this pawn, if this pawn has no possible moves. So that's how it works. Let's add maybe this pawn here, and now select this black pawn, and see that it can only go forward because we didn't do the same logic for it. We're going to create here, so column now will be column minus 1, and here column plus 1. This becomes false, and we send another true later on, and this the same. Now our pawn here can go forward and any of these two pawns on the diagonal. This is a simple way of increasing the capabilities of our function here, check valid move, by blocking if opposite color and blocking if empty, keeping two possibilities, which are very nicely added because they can be quite generic. And if in the future we want to use this for any other piece, we won't, but we could if we do like to. And finally, we can go to the king. So here we have the king. Again, the same logic that we had before this one. Check the valid move, just like the knight, sending the board, the square, and then the coordinates, and getting the move back. Copy paste this here. Like this, and now we copy paste this one. Like so, like so. Almost there. Here. This is our king. So now if we select the king, no, I'm playing with black, can only go to these spots here. Now select the white, can only go here. Keep on going, and I want to show you something. The king now can move, but my king can move into check because that's not allowed, and this is a problem. The king can never put it itself into a check position, like here. This would be game over, right? Then you just give up on the game. So because of that, we still need to analyze on all of our moves here, all of them, if the king will be in check and act accordingly. So we need to allow these kings to always be prevented from being checked whenever any of the pieces move. And why do I say any of the pieces move? Because we can say that the king, although not moving, can get in check by a discovery attack, for example. So another piece, when I move this piece here, for example, another piece could be attacking the king. So there's plenty of things that we need to check here in order to make the check, the king check, valid. For now, I'm not going to care about it. We just wanted to finish the movement of the pieces by being blocked by the others. And it's what we have as well. And just as a final remark, we're still also moving some special movements. For example, castling, both king side and queen side, and the en passant. Like the pawn movement is special when the other pawn moves in specific positions and everything, we get there. So our movement is basically implemented, but it is still not ready, especially because we still also need to implement, now that I think of it, the promotion. So whenever a pawn reaches here, the pawn is promoted. Some special movements that we need to take care here in our code still. But for now, again, this is very solid and it's looking very good.